Don't mind the outside sounds, they're just outside, okay? Anyways, so I was doing some thinking, some dangerous thinking, in fact, and I was wondering, could thermodynamics play a role with the singularity density of a black hole alongside the effects of vacuum energy, vacuum pressure from space outside of the singularity, electron capture due to density from gravity and magnetic forces, beta decay rates, centrifugal force, rotational force, friction from frame lagging, repulsion from the strong nuclear force due to exponential density and pressure towards the center of the black hole, the forces from annihilation of particle and antiparticle particles, which create various other particles, and the neutrino and radiation evaporation between the singularity and the event horizon relative to the total particle mass of the black hole and its volume relative to the density limit of a neutron. Now that's a lot, right? That's a lot to consider, and I think that's a good place to start off is by breaking down each of these points because I did the thing and asked Google, right? The thing that it's Google's apparently now the leading AI, so I don't know. But since we're creating things to think for us, and I need ways to bounce these ideas, since I'm not like a professor or anything or in college program, nor do I have the time to participate or the funding to participate. I might actually think of doing GoFundMe's for a bunch of other things because my car shat the bed yesterday too. So that's a lot of other things, but before my car shat the bed, I was thinking of this, right? And when I searched or asked Google this question, and we can also look at other AIs, but we're just going to stick to Google because in order for us to not lose sight of everything and yada yada, blah, 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 and just understanding how Google works as a search engine, not just an AI, because we're looking for all these different things that are relative to the idea of quantum gravity. And there's still one more other thing that I forgot, even in this whole question, is the Higgs boson. What happens to the Higgs boson during a black hole? Because if we can understand black holes and, the evaporation of neutrinos and radiation, since that is what is experienced, and you can look this up in scientific journals and stuff like that, like all these things exist, right? Just fundamentally, like all these things that I'm mentioning, like beta decay rates of a neutron, centrifugal force, rotational force, etc., because the black hole is rotating, after all, and almost at the speed of light, relative to when we look at what a neutron star is, and the fact that if a neutron star gets to a certain critical mass or point, it turns into a black hole. Or a quark cloud, whatever the hell it is, and then a black hole. So between that whole transfer of or transformation of matter, essentially, because that's what it is, due to the amount of stuff that's going on, because there's a lot of forces in play when it comes to the collapse of a star. And these are a bunch of things that I'm trying to account for, including the idea of frame lagging, as personally, and what I consider to be what gravity really is just a frictional force from space itself. Because, as we know, space is made up of stuff, it's not just empty. And that stuff that's within space, that's free floating in space, it moves alongside because the particles at that level within space, they are able to interact with each other. That's where the quantum gravity lies. That's where people just don't seem to understand the local causality that is in effect, which is it's super deterministic in and of itself when it comes to the expansion of space, because it's all relative to the local environment. That has a key role in how a black hole exists or doesn't exist, because a black hole literally is such a dense set of reactions that are happening simultaneously within a point in space-time that it breaks space as we observe. So this whole question is based off our current observations of physics, of what's going on, that we understand so far, and putting it all together, because these are all factors that play into the existence of a black hole and its properties, everything else, is what we observe and what we seem to understand based on our current models of physics. Now, like I said, the only thing I have to do is also account for the Higgs boson, because if that's what gives space mass, right? Or gives things in space mass, I suppose, or the value, maybe it's like a kind of counteracting force which might contribute to the vacuum energy and vacuum pressure that's being applied from the outside of a singularity. Because in order for a black hole to exist, it needs to bend space-time. To bend space-time, it has to, I mean, it's, as we observe, it's spinning almost at the speed of light, and it's a huge mass. It's like a huge, it's the mass of a star, a huge star, right? Not a little star. They don't, little stars don't typically collapse into black holes unless they merge into another star that's nearby, or if it's in like a binary system, trinary system. So my idea, at least, since I don't have friends with PhDs in physics or anything like that, is, just explore this question and to expand upon it. So I want to at least show you what I've seen by applying this question to Google. You know, we can use it to AI, because after all, AI's, their main purpose is to go through what they're able to go through, which, I mean, in Google's case is essentially almost the whole internet. There's some bias, but we're not talking about politics. We're not talking about bias stuff. We're talking about things relative to truth and existence and black holes. Trying to figure out what we need to account for in order to really understand where quantum gravity comes from. And my belief is that it comes from relativist, like the sum of frame lagging forces within local space from one mass, as like a mass, say like a planet, for instance, like our planet. When it rotates, it's rotating like space. There's an interaction at that level between probably our atmosphere, and this is possibly why our atmosphere doesn't also just like dissipate into space, because there's an opposing vacuum pressure force from space itself onto the planet. And since it's rotating at a certain speed, it's allowing the atmosphere to maintain itself over time, as well as depending on how we interact with our atmosphere in our environment, as we see, as well as, other things. There's so many factors, and this is an attempt to try to touch base on what those factors are, and to try to at least organize the thoughts and the ideas relative to the idea of quantum gravity itself. So anyways, besides the long-winded intro, etc., I hope that it copied. Let's do the damn thing. Let's do this. Let's not ask Jeeves or anything. So, I'm curious. So, in essence, with the overview, responds, yes, thermodynamics could play a role with the singularity density of a black hole, but in a way that is vastly more complex and speculative than your question implies. Interesting. While your question includes many relevant concepts, it also contains some physical assumptions that are not supported by current theories of gravity. The interior of a black hole and the true nature of its singularity remains one of the biggest mysteries. This is a different answer than what I got last time, so it's interesting to see the differences. Because I can do a second stream and show you what I saw the first time. This is very interesting. Singularity is one of the biggest mysteries. Yeah, no shit. That's why I'm asking this question. Because our two most successful theories, general relativity and quantum mechanics, break down at the extreme. Yeah, I know. I'm trying to account for a bunch of stuff. So thermodynamics and the singularity density partially supported. The link between black holes, thermodynamics, and the singularity is okay. Black holes have thermodynamic properties such as entropy proportional to the area of their event horizon and a temperature, the Hawking temperature. The connection between these observable properties and the singularity itself is unknown. Quantum gravity is required to fully understand. Yeah, I know this is why we're asking this question. But, as you see, yeah, quantum gravity is required. So where you have a connection here with the question, because I don't even mention quantum gravity. I'm just talking about the thermodynamics. Okay, and there was an interesting report that came out with an equation for thermodynamics in the wave function realm, in the quantum realm. Like I said in a previous video, I feel like that's going to be crucial in understanding how quantum gravity reacts. So now it touches on vacuum energy pressure outside the singularity. Speculative, this is not part of the standard black hole model, though it is a focus of alternative theories like gravistars. Interesting. Interesting. So I'm not the only one that's thought about that. In the standard model, the vacuum inside the event horizon but outside the singularity is simply a region of warp spacetime, and its energy density is not understood to influence the singularity directly in this manner. Yeah, it doesn't affect the singularity, but I think the singularity affects it. So other way around. But yeah, obviously, like, yeah, it's that's what's warping the space time is the singularity spinning at almost the speed of light. So there we go with that. That is interesting. So maybe if I reword this question in such a manner that it understands it inversely to what it thinks and understands the question in, maybe my delivery will help in facilitating that understanding. Electron capture due to density forces supported, but only up to a point. Interesting. Matter collapsing to form a black hole undergoes electron capture and other fusion processes as it gets denser, similar to a collapsing neutron star. Before the event horizon forms, the immense gravity overcomes electron degeneracy pressure, yes, triggering proton electron fusion to form neutrons. However, once the event horizon forms, general relativity predicts total gravitational collapse to a singularity, overcoming all known forces, including the nuclear forces. So that has to do with all the stuff that's happening on the outside, kind of. It's relative to maybe the vacuum pressure as well, or the centrifugal force from the rotation of the singularity. Um, Beta decay rates inside the black hole not supported. Beta decay, a function of the weak nuclear force, would be overwhelmed by the total gravitational collapse described by general relativity. Interesting. Any matter that undergoes beta decay would be quickly compressed beyond the point where the decay rate would be a relevant factor. Huh. Interesting. But would it still decay? So that's why it's like, hmm. Centrifugal forces and rotational forces. So this is something that I learned about previously that had to do with the whole frame lagging. Supported in a rotating Kerr black hole, these forces are critical. However, they do not prevent a singularity. That's not what I said. However, they do not prevent. I'm not saying that prevent. I'm saying that it makes the singularity part of their creation. I mean, if the centrifugal rotational force is what's dragging in the stuff to make the event horizon. All right, well, rotation fundamentally changes the shape of the singularity, stretching it into a ring and influencing the space-time geometry near the event horizon. However, it does not prevent the formation. Yeah, I know. I'm saying it makes it. If anything, you're saying that if the event horizon is what's the critical factor here, and the gravity from all the crap that's within the event horizon pushing in on the singularity as it's rotating is being fueled essentially from the outside in. Okay. Repulsion from strong nuclear force. Not supported. This is the opposite of what it told me the other day. Interesting. Not supported. This is a critical misconception. A neutron star is supported against gravity by neutron degeneracy pressure, which is an effect of the strong nuclear force at extremely high densities. A black hole forms when the gravitational force becomes so strong that it overwhelms even the strong nuclear force, leading to a breakdown of all known forces and structures at the center. Okay, okay, that was the point. That was what didn't I say? Alongside the effects simulator, electron capture due to density from gravity and magnetic forces, beta decay rate, centrifugal force, rotational force, friction from frame lagging, repulsion from the nuclear force. That's what I'm saying. Repulsion from the strong nuclear force due to exponential density and pressure toward the center of the black hole. And what does it think? So the gravity force, it's saying that the gravity force overwhelms that repulsion force. I mean, Okay. Yeah, I mean, but it's still a force that's acting. Okay. Annihilation of particles and antiparticles. Supported particle antiparticle annihilation is a quantum mechanical process that would occur inside a black hole as matter gets compressed. Oh, I was thinking of the event horizon, but okay, that's even more interesting. The standard model of black holes suggests that any radiation produced would be trapped behind the event horizon. However, the quantum fluctuations at the event horizon are responsible for the thermal effects of Hawking radiation, and obviously, it's like the rate of decay of the evaporation and etc. All right, neutrino radiation evaporation between the singularity and the partially supported is widely accepted that some form of radiation emanates from a black hole, but it is not from within the event horizon. Hawking radiation is a quantum effect that arises from particle antiparticle pairs forming near the event horizon, with one particle escaping and the other falling into the black hole. The radiation is created at the event horizon, not between the event horizon and the singularity. Hmm. Created at the event. Isn't the point at the event horizon the point between the singularity and the event horizon? Isn't I don't huh. Okay. I mean it's relative though, and density limit of a neutron. Non applicable, this limit applies to neutron stars which are stable objects. A neutron star okay. Prevented from further collapse by neutrons. A black hole forms only when the initial mass is great enough to overcome. That's what I mean. That's exactly what I mean, actually. Okay, yeah. All right, cool. That's what I'm. It's just probably how I worded the question this time around. I don't know. It's the same question I asked it the other day, and this is some of this stuff is. It's like yes, it understood like my delivery the first time, and now this time it's kind of like I don't know. It's misunderstanding the question. So interesting, but that's yeah. How thermodynamics relates to black hole singularities, such as temperature and entropy, are properties of the event horizon, not the singularity. This is what I'm curious of, though, is, I mean, something's happening within the singularity. There is a observed temperature, is there not? Black hole entropy. Jacob Bergson was the first to propose that black holes have entropy, and Stephen Hawking later confirmed that this is proportional to the area of the event horizon. Yeah, that's all right. So this is interesting. Black hole temperature. Hawking's discovery of Hawking radiation established the black holes emit thermal radiation have a non-zero temperature inversely proportional to their mass. That is yes, that is what I'm saying. That is yes, they have a non-zero temperature inversely proportional to their mass. So I mean, bigger mass equals colder, right? The bigger the singularity, then right? Is that's what I'm saying? So bigger singularity, bigger event horizon, bigger volume. Even though they don't measure that, well, they do. They have the Schwarzschild radius, but that I'm okay. It's a fucking circle. I don't know how it's. I mean, we're trying to figure out what's going on within the circle. That's the question. Quantum gravity and the singularity, ultimately a complete explanation of the singularity's behavior and how it reconciles with thermal properties of the event horizon, requires a theory of quantum gravity. So this is what I'm saying. This is where the point that we're at. Okay, and this is why I'm mentioning all these things, because they're all relative in some way, shape, or form, whether they're supported or not. I mean, I wasn't trying to see what's supported and what's not. It's even the ones that weren't supported, they're relative to the idea of a black hole. It's just thinking that I'm implying something else. I don't know. Okay. Thermal properties of the event horizon requires that the quantum theory of gravity. This theory would explain what happens to space-time matter when gravity becomes overwhelmingly strong. Some theories propose alternatives to a point singularity, such as a fuzzball of strings in a string theory or a loop quantum gravity effect. They're thinking of strings and worms and all this other stuff. Meanwhile, I'm thinking of spinning circle, and centrifugal force, and the force from that, from the stuff that's being attracted to it, just like how planets work, essentially. And then it didn't mention. I mentioned frame lagging. You didn't address it this time. Interesting. That's another. I mentioned frame lagging. All right, so I'm gonna have to upload the freaking what I saw the first time when I asked this same exact question. This is monkey poo. What the hell? I feel like Gemini became more pretentious over the last week. That's not. Alright, well, we're gonna have to reword this question. And also add in the Higgs boson. I'll do that. Now, before I do that, I want to show you what I saw the first time. I just gotta upload my screenshots real quick, and we will get them. I don't know what order they're in, because it went in more detail. It's like it didn't bother this time around. It's very interesting. Share. Right, hopefully I have enough space in my drive. Do do do. Make a new folder. Uh, oh. All right. Well, as that uploads, let's work on the question, and we'll do this probably for a little bit longer. I'm just glad they finally stopped doing the lawn mowing stuff outside. Oh my god. All right. So, could thermodynamics play a role with the singularity density of a black hole? Due to vacuum energy and vacuum pressure from space. I should do between the event horizon and the singularity. That is not singularity. Due to the effects. Due to the effects of the forces from the sum of interactions due to the density from gravity from the mass of the event horizon being attracted towards the singularity due to Magnetic forces. This I'm gonna cut. Yeah, because these are all the forces: centrifugal force, rotational force of the singularity, friction, the sum of forces from frame lagging of space and the event horizon due to the rotational forces of the singularity, which overpowers the beta decay rates, repulsion from the strong nuclear force due to exponential density. Right, here it's and repulsion from the strong nuclear force of what's within the singularity due to exponential density and pressure towards the center of the black hole. While the forces from annihilation of particle antiparticles, which creates various other particles in the neutrino and radiation evaporation between the singularity and the so at the event horizon, as it said, at the event horizon relative to the total particle mass of the black hole, and its volume, and the volume of the singularity neutron as the forces overwhelm the no, I should just say similarity as the sum of the forces relative to the rotational mass of the singularity overwhelms the forces the neutron density limit within the singularity. Okay, okay. I okay, maybe. And then the last thing we need to add in is the Higgs boson stuff. So what because if Higgs is what gives, mass, right? Or the value of mass. And I mean, if it's bending space, then I don't know. Is like the sum of the Higgs bosons that's within the event horizon, is that what's causing the density? Because density is relative to mass and volume, right? Clearly, the volume's small, but the mass is massive, and the density is going toward infinity, especially toward the singularity in the center. So something there is breaking. It's obviously not infinity, it's just constantly tending toward infinity because it's past, the neutron density limit, and there's so much going on, like immediately going on within the singularity due to all the forces interacting at the same time and then maintaining that structure of the black hole over time. So, Higgs boson relative to black holes. Higgs boson is not okay. Yeah, I know that. The standard model, as they are governed by incompatible theories, particle physics. However, theoretical connections. Okay, yes, this I'm part of that. Yep. Okay, there's also possibility of microscopic black holes producing Higgs bosons. What? Different physics. Okay, Higgs boson is an elementary particle in the standard model. A black hole is an object governed by Einstein's theory of general relativity, but not yet unified. Yeah, because this is the quantum gravity. Yes, okay. Higgs field versus gravity. The Higgs field gives mass to particles, while gravity is determined by the mass of yes, including the mass granted. So where do we find Higgs bosons? Are they free in space? Are they connected to stuff? How do they exist? Speculative theory, theoretical connections, phase transition inside a black hole. Yes, cause the Higgs field to return to a symmetric state. Huh. Would have a value of zero or make an R particle's mass. That's kind of what I'm thinking. This could prevent a true singularity from forming and lead to exotic phenomena such as a bounce or entry point to another unit. All right, no, all right, you're cooked thinking that far ahead. Because our theory is that black holes are the personification of extinction. So this could prevent, okay, Higgs production from microscopic black holes. Higgs vacuum. The Higgs field is a metastable false vacuum. These primordial black holes could nucleate transition to a more stable true vacuum, potentially having catastrophic consequences for you. Okay, that's not. Hmm. Where are Higgs? Oops, Higgs bosons found in space? Are not found permanently in space. They must be created in extremely high energy events like those cosmic rays colliding with the Earth's atmosphere. When created, they exist for a fleeting moment before decaying into other particles. Okay. Therefore, while the Higgs field is ubiquitous in space, giving particles their mass, the Higgs boson particle itself is short-lived. Transient particles that is not a permanent part of the cosmos. High energy particles from space can collide with atoms in Earth's upper atmosphere, occasionally producing Higgs bosons. Okay, so I'm thinking about the Higgs field then. Fundamental particle, the quantum excitation of the Higgs field. It's like a ripple because, yeah, the gravitational waves, right? When we look at, two black holes merging together and you observe the ripple of gravitational waves coming from that interaction, that's interesting. So Higgs bosons, they must be tied to black holes in some way. It must have to do with the interaction between the event horizon and the singularity, which breaks the Higgs field in essence, or well, stretches the Higgs field itself. Hmm. Because I mean, the question of if black holes have mass is, I mean, obviously they have mass. They're not photons, right? That's a very easy question to answer. Obviously, we can't put a black hole on a scale and weigh it or anything like that. So this is where the confusion comes from, and hmm. So the Higgs field and the Higgs boson, those are the two things left that I have to kind of piece into this whole question. So could thermodynamics play a role with the singularity density of a black hole due to the effects of vacuum energy and vacuum pressure between the event horizon and singularity, which is affected by the creation of Higgs bosons. This is the other thing too. If like within the singularity, if electron degeneracy, whatever the fuck I called it, or they call it, if that, hmm, if that's what's going on, like basically constant nuclear fusion, I mean, like a neutron star, but to a point where it's so dense that, I mean, forces breaking it. Affected by the creation of Higgs bosons within the. I should just say from the black hole. From the black hole, which affects the surrounding the Higgs field surrounding the singularity as it rotates near the speed of light, being fueled by the reactions rapidly occurring with the forces from the sum, or the sum of the forces by the sum of the forces from the reactions rapidly occurring within the singularity around the singularity. Thank you. All right, I think that, yeah, I think that's it. I think that's it. I think that's it. That's a big question. Can Google do it? Can we do it? Can we? Can we? Curious. Is it too big? Is it too big? Okay. Did it? Okay, it did. Was there a limit? No, there was not a limit. Okay. Okay, yes, thermodynamics is a critical area of study for black hole physics, including the singularity, but the long list of proposed effects is speculative and involves a mix of established principles and theoretical frontiers. The connection is strong because of quantum effects like Hawking radiation and the concepts of black hole entropy, which is related to the black hole's event horizon area, not singularity density. Okay. While current physics cannot describe the exact state of matter at the singularity, yeah, I know. That's some of your ideas are hypothetical. The principles of thermodynamics are essential for understanding the broader behavior of black holes and the ultimate fate of matter that falls into them. I'm trying. I'm trying. All right, this is interesting. It's different than this table that it gave me, but it. Ooh, okay. How thermodynamics relates to black holes. Black hole thermodynamics, the laws of black hole mechanics are mathematically analogous to the laws of thermodynamics. Yes, that was. Yes, this is the whole idea. Yes, okay. For example, the area of the event horizon A acts like entropy S, and the surface gravity K acts like temperature T. That's interesting. Okay. Okay. Um, Hawking radiation. Quantum mechanics shows that black holes are not completely black. They emit thermal radiation, known as Hawking radiation. This is the key link to thermodynamics. Yes, is what gives black holes that. Black hole entropy. The concept of black hole entropy is directly related to the surface area of the event horizon, not the singularity's density. So this is I'm not trying to relate black hole entropy to necessarily the density, but there must be a connection to either of those. The information paradox. Hawking radiation leads to the information paradox, a major problem in physics. It's unclear how information that falls into a black hole can be lost, as this would violate principles of quantum mechanics. This is a major area where thermodynamics and quantum mechanics clash. Because whatever goes into it is getting broken down due to the immense forces that create the density. It loses its trace. It loses what it used to be, where it was, and anything, especially since we can't observe within the singularity. There's no way for us to observe within the singularity. We can only model it by trying to at least consider all these different factors, which is the kind of the point of modeling quantum gravity. But if we're going to figure out quantum gravity, we need to figure out what's going on with the singularity density. That what's causing the singularity density to tend toward infinity, right? And that would help to also explain the temperature, being inverse to its mass. Because, its mass is related to its size, obviously. Even if it's super dense, there's still relativity with mass to its volume. There's density that exists. It's just constantly tending toward infinity. So, forces, your list of forces is a comprehensive thought experiment that describes the many factors at play as matter falls into a black hole. While these are all valid forces, the interaction between them inside the event horizon is not fully understood. Thank you. Well, thank you for gaslighting me back. So this is interesting, right? This is why, again, that's why I'm listing all these forces. It is all relative. Now, the Higgs field. The idea that the Higgs field might turn off at extremely high temperatures inside a black hole is a theoretical possibility. That's very interesting. If the field were to break down, it would have a profound impact on particle masses. Yeah, and that's probably the only way that you can get infinite density is if that breaks, right? Especially since the observed volume of a black hole singularity is a lot smaller than the star that it came from. So something has to break there, or at least constantly being pushed to that limit, to a point where the Higgs field is constantly being pushed away. Vacuum energy, whether vacuum energy is relevant, is highly speculative. Some advanced theories propose modifications to black hole mechanics to account for it, but these are not yet established. Yeah, this whole thought process is maybe ahead of its time. But focus on, the current state, focus on the event horizon. Okay, yeah, because that's what we observe. Need for a theory of quantum gravity. A full understanding of what happens inside a black hole will likely require a theory of quantum gravity, which combines general relativity and quantum mechanics. Experimental limitations. It is currently impossible to directly observe. I just said that. Okay. So this is where we're at. I think to understand what's going on within the singularity is the next step. Because if we can philosophically at least get the idea of that, the sum of the forces that are going on, because all these forces that we listed, they're going to be a part of this equation, whether you like it or not. I mean, the whole standard model is a gigantic mess of stuff, but it, by the end of the day, all these forces are relative to a black hole, and if they're relative to the singularity, I mean, the creation of the singularity, the existence of the singularity itself, I mean, they're going to be involved with quantum gravity. So, at least this is probably where we stand currently, is taking into account everything possible. It still didn't mention frame lagging, which I think that's the thing. So let's end off with because the past ones that I mentioned, like the past questions that I had involving frame lagging, rotational forces, essentially. Mm, I think if we can rewrite general relativity and, well, Newton's gravity, or the gravitational constant, to be relative to density instead of mass, right? Or density over, well, density times volume, whatever the equation is going to be. If you switch on mass with density and volume, maybe we'll get something interesting from that. Maybe we'll have something that can connect it all. Because what we know about the singularity, at least theoretically, and what's accepted, is that the density tends toward infinity. Obviously, you can't weigh the thing. You can measure the Schwarzschild radius, and then you can measure the observable volume of the singularity. Or, well, you don't see it. You see the event horizon around it, but you can see the light ring and everything else. You can at least estimate close enough relative to that, and then at least get somewhere. Or maybe that's where we need to start accounting for all these forces that we listed off today. So now let's go to the drive. See, yep, barely any storage left. Oh, my tummy. Oh, yep, there we go. Come on. All right, so this was interesting when I brought up, so density from yada yada yada, blah blah blah. It's the interplay. So the interplay between thermodynamics and the phenomena you listed could significantly influence the nature of a black hole singularity, though much of this speculative physics at the edge of our current understanding. So yeah, this is from a few days ago when I asked it. It was a little bit more. It was more comprehensive than when I was simpler. Black holes are not perfectly black. Yeah, I don't know. Where is the frame lagging? Quantum fluctuations and collapse, evaporation and neutrinos. Yeah. Effects of extreme forces and interactions, electron capture and beta decay. As matter becomes unimaginably dense, the gravitational force would overcome. Yeah, so this is, yes, this is not as mean as it was today. That's for sure. Volume. The black hole's event horizon area is directly related to its entropy, but the black hole's interior volume, particularly near the singularity, is not understood. In classical physics, in quantum gravity picture, the volume might not go to zero, but rather to a minimum non-zero value, potentially replacing the singularity. Interesting. Because, I mean, there must be a displacement of the Higgs boson. Or the Higgs field. Because that is the only way that you can turn that mass. And, I mean, there's an observable volume. The volume is more easily measured than the mass, right? So I think that might be where it is. It's that interaction with the Higgs field and what all these forces have on the Higgs field, because the Higgs field is a field of energy, and it, gravitational waves, it goes through the Higgs field because it's, interacting the particles that are coming out from the black hole, and they're interacting with the event horizon. They eventually escape into space somehow. They they either annihilate or they get the heck out. They don't go back in. They don't do anything. Maybe they float around the event horizon, and then that is more force against the singularity, and that's maybe where the infinite density is maintained. And because of that, the forces from frame lagging. Why is it not mentioning frame lagging? I might have uploaded the wrong shit. Hmm. Let me look through my phone again. Let me find it. But this is what I'm also saying. Is like, depending on the day that you ask Google, even if it's the same exact question, because this was the same exact question that we started with today. Could thermodynamics play a role? Blah blah blah. Density, just so you can see it. I mean, you pause and freaking zoom in if you want. I'm not doing all that work, but this is just a stream. But that's the same as this. That was the same exact question, and that was the response that I got. I want to maybe re-ask because I'm very curious of what it thinks about frame lagging. Maybe I'm trying to gaslight it, but who knows? So let's do this. Take 3. I mean, the only other thing I could do is write down all of these equations, like a tier list video type thing. Write down all these equations that are relative to the forces that we're talking about here, and try to find where the relationships are. I think that's the part of the problem too, is with trying to figure out quantum gravity, is that there's so much that it's involved with because it's such a fundamental force at such a fundamental level. I mean, well, again, we see how long the actual equation for the standard model is. It's probably just way too intensive. It's way too intensive for me to figure out on my own, let alone even with an AI assistant. But obviously, it's taking so long collectively because I feel like we can't really get our thoughts together on all of this. And at least, I mean, with this conversation, with this question, this massive question, it clearly touches at the heart of quantum gravity. It clearly, in order for all these forces to understand their interaction with the density of the singularity and trying to understand what's going on within the singularity, I mean, as the form of matter is honestly on, it's like a, again, when we go from a neutron star to a quark cloud to a black hole, it's the transition of state of matter is kind of ambiguous because it goes from like a superfluid from as a neutron star, as that's how that energy is measured and the momenta and everything else. When it comes to pulsars, it's a superfluid, and then obviously it goes more condensed to a quark cloud when it gets to a certain limit. So it's very counterintuitive, and then it goes to a black hole, which seemingly is like beyond a cloud for whatever reason. It's like a solid that went, or well, a superfluid, well, basically a solid, because that's when you think about, a star's collapse, when the core becomes a solid iron core, because of the density and stuff. It goes from a solid to a superfluid to a gas to it's like the opposite direction when but not really the opposite. It goes in tandem with thermodynamics and supports the Hawking radiation, the mass is inverse to the temperature type beat. So it's basically it gets beyond that limit where things start working inversely, which is a theory that we've been talking about, or just an idea we've been talking about on the channel for a bit. And I mean, the transitional states of matter, when we look at from pulsar to black hole, depending on the amount of mass that's involved in the collapse, it's relative. Philosophically, it's relative. And I mean, realistically, it's relative. So this is where it's hard to understand what is going on because there's so many limits again that's broken down. There's so many aspects of the physics that we know that we can observe that's broken down that we don't know what's left. But also at the same time, it's hard to really understand like the event horizon itself. Like it's like a photon cloud because there's like so much going on. I mean, to us, it looks like a cloud from the outside constantly rotating around the singularity. And that's where I see frame lagging. The sum of that frame lagging force comes into play. Is like a inverse of our typical gravity, but or inverse to the centrifugal force rather, because those forces, when it comes to rotation, like when we think of like a spring rotating from a center point with a mass attached to the other end, and how it moves outward the faster that it rotates, it's kind of inverse to that inversal force from the frame lagging that's maintaining the event horizon, maintaining the gravitational pull toward the singularity. I mean, it's rotating again almost at the speed of light, that amount of mass. So the forces that are involved with that rotation and the fuel that's required to maintain that rotation, even against, mind you, against the event horizon, against the forces of what's in the event horizon, of all the things that are in there. That's, I think, where we need to flip the way of thinking in order to understand the singularity. So, I don't know if I ever have time to write all the equations down and parse through it, then great. But this is an extreme undertaking for any single individual, but this is at least the best I can do for now. I'm still looking for the frame lagging mention, but I was just busy thinking and yapping at the same time. This is interesting to say the least. Neutron density limit, Tolman Oppenheimer Volkov limit. So that was one of the considerations that I did not mention this time. Singularity problem, vacuum energy, vacuum pressure. Yeah, on capture. Yep, and then the Kerr black hole, which I mean, essentially all black holes. There's the frame lagging, frame dragging. Yeah, it's a frictional drag force from the centrifugal force of the singularity. That's what I'm considering. So here it is. Can I just share to Google though? Okay. I'll just share the one. The question was a little less intensive when I asked Google, but it does make a mention. So maybe if I reword this, but let me show you. Just be like, oh, it's not you know relative. It is. I mean, a rotating black hole drags space-time with it, an effect known as frame dragging. This creates a region called the ergosphere, where it is impossible to stand still. I mean, due to that rotational force. That's Objects inside must move with the black hole's rotation. The friction from this frame dragging would affect the thermodynamics of infalling matter in the black hole itself. That's the that's the idea that I have, at least, where the limit comes into play. And maybe frame lagging, frame dragging. And I'm going to cut this. And we're going to put this up closer. So right there. From all right, so this is interesting. Maybe. The big run-on fucking question, but you know. So, could thermodynamics play a role with the singularity density of a black hole? So maybe. So since thermodynamics plays a role with the singularity density of a black hole due to the effects of vacuum energy and vacuum pressure between the event horizon and the singularity, which is affected by the creation of the Higgs bosons from the black hole, which affects the Higgs field surrounding the singularity as it rotates near the speed of light, being fueled by the sum of the forces from the reactions rapidly occurring within and around the singularity from so against the sum of the frictional forces from frame lagging, frame dragging of space in the event horizon due to the rotational force of the singularity itself. The effects of the forces of the sum. Okay, let's try this. Or well. All right, let's try it. I mean, it has conceded multiple times that yeah, that's exactly how it works. I just want it to comment on the frame dragging. All right, interesting equation. Okay, yeah. I mean, it's not gonna. Ronald's premise contains several misconceptions about the nature of black hole singularities and fundamental physics. Must reconcile quantum mechanics and general relativity, a goal not achieved by an equation that misrepresents existing physics. Permeates all of spacetime, and its presence is not determined by the black hole. And that's so the black hole's immense gravitational field affects the Higgs field and its ability to impart mass to other particles. That's okay. So I need to reword it. It's not made of matter. It is a boundary in space-time, a point of no return. Matter crosses the event horizon and collapses toward the singularity. Premise idea of the mass of the event horizon. Okay. Attract to the singularity due to the magnetic forces is therefore incorrect. Okay. Magnetic forces do not draw matter into black hole singularity. Magnetic forces are present in the accretion disk and can accelerate matter into relativistic jets. They do not overcome gravity to pull matter from the event horizon to the singularity. Well, wouldn't add into the gravitational pull? Not overcome it? Okay. Strong nuclear force does not repel matter inside a singularity. Yeah, it's overwhelmed by fucking gravity. I know. Okay. Electron capture and beta decay are not competing forces inside a singularity. Capture and beta decay are nuclear processes that occur under extreme conditions, such as during the formation of a neutron star. Inside a singularity, all nuclear forces are overcome by gravity, and these processes would cease to be relevant in the way described. Conceptual problem of combining gravity and quantum physics. The challenge of creating a theory of quantum gravity is far more complex than finding a new force equation. The fundamental concepts of general relativity and quantum mechanics are at odds. Yeah. Use gravity as the curvature of smooth, continuous spacetime. Quantum mechanics tries forces and particles in terms of discrete quantized units. An equation for quantum gravity must somehow unite these two disparate ideas and describe the quantum behavior of spacetime itself. Popular, okay, whatever. Limitations of describing a singularity, even if the physical premises were correct. A single equation is unlikely to describe a black hole singularity, an area of infinite density and gravity and general relativity. The known laws of physics breaks down, or whatever. So it gave up. It gave up. Uh, Interesting, but the Higgs boson part, sure, I can freaking take into effect. Which, all right. So since thermodynamics plays a role with the singularity density of a black hole, tending towards infinity due to the effects of vacuum energy. Yeah. In the event horizon, which is affected by the not the creation of Higgs bosons, which affects the speed of light, being fueled by the sum of the forces from the reactions rapidly occurring within and around the singularity against the sum of the friction forces due to space in the event horizon due to rotational forces of the singularity itself, the effects of the forces from the sum of electron capture interactions due to the density. Density from reduces density from the sum of frame dragging force and gravitational pull from which maintains all matter being attracted to the singularity due to magnetic forces, centrifugal force. I'm gonna keep adding frame dragging until it fucking recognizes it. Frame dragging from centrifugal force, rotational force, singularity. Which overpowers the beta decay rates and the which was our black hole. And it's kind of repeating. Maintaining the density and pressure towards the center of the black hole, while the forces from annihilation of particle and antiparticles, which creates relative to the total particle mass of the black hole and the volume. Particle mass and volume of the singularity as the sum of forces relative to the rotational mass of the singularity overwhelms the neutron density limit within the singularity. It's a lot of repetition, but I'm curious. What does it say now? Does it say it's more misconceptions or not? Interesting. I'm gonna force Google to figure this out. Your detailed hypothetical scenario, while creative, contains okay, yeah, sure. Because these inaccuracies in equation based on the described forces could not accurately model quantum gravity. Alright, so what's wrong? Scientific inaccuracies in the user's premise, vacuum energy, and pressure inside of. No! Outside, not inside. No! The nature of the singularity. Your idea of the singularity being affected by forces like vacuum pressure and frame dragging from friction is incorrect. The singularity is not. It's not being affected. It's the one causing the frame dragging. It's not a physical object, but a point where general relativity's equations. I don't care. It's the fucking black space that you look at, that you observe, the absolute darkness. There's something there, obviously. Fucking Christ. Singularity, no. It's not a physical object, but a point where general relativity. Yeah, no shit. We don't know. Frame drag and friction. Frame drag and friction is the effect of rotating mass twisting space-time, not a frictional force, resisting the singularity's. What is doing the twisting of space-time? The singularity. It's I have to reread what did I do wrong? Since thermodynamics plays a role in this, with the singularity density of a black hole tending toward infinity due to the effects of vacuum energy and vacuum pressure between the event horizon and the singularity, which affects the Higgs field surrounding the singularity as it rotates near the speed of light, being fueled by the sum of the forces from the reactions rapidly occurring within and around the singularity, causing the sum of friction forces, or causing frame lagging. Or so what does it explain? Frame dragging friction. Frame dragging is the effect of rotational mass twisting space-time. Yes, so that's not frictional force resisting. Friction occurs in the accretion disk as we looked earlier, that's what it said the other day. And it actually said that this had to do with what was the picture? A rotating black hole drags space-time within an effect known as frame dragging. This creates a region of the ergosphere where it's impossible to stand still, objects outside. The friction from frame dragging would affect the thermodynamics of infalling matter, and it's right there. God. Okay. Idea that magnetic, centrifugal force, and rotational forces can overpower electron capture beta decay. A strong nuclear force is a misunderstanding of physics of stellar collapse. When the gravitational pressure becomes immense enough to create a black hole, it overpowers all these other forces, making them irrelevant within the singularity. That's so what's causing the gravitational pressure? Particle annihilation at the event horizon. Period of the event horizon does not involve annihilation at the black hole absorbs one particle with negative energy while the other escapes, causing the black hole to slowly lose its mass over an incredibly long period. Higgs field effects near the singularity. While some speculative theories suggest a profound interaction between the Higgs field and extreme gravity, your premise of the Higgs field being affected by rotating near the speed of light is not part of any accepted or prominent hypothesis. Higgs field permeates all of space-time and is known effects do not match this description. Okay. Quest for quantum gravity. Current theories of quantum gravity are based on unifying two pillars of okay. String theory, okay. Okay. I mean, sure, string theory is probably right, but oh my god. How am I wording this incorrectly? Maybe it's just too much. Thermodynamics plays a role with the singularity density of a black hole, tending towards infinity due to the effects of vacuum energy and vacuum pressure, or due to the effects of effects on the Higgs field surrounding the singularity as it rotates near the speed of light. The forces from the reactions rapidly occurring within it. Oh, I actually spelled that right. Did I? I did. Occurring within and around the singularity, causing frame lagging. Uh, Frame lagging, frame dragging of space around it, which maintains the gravitational pull. While the rotational force from the singularity causes frame lagging, frame dragging of space around it, which maintains around it, which maintains the gravitational pull of the event horizon. It rotates near the speed of light, which causes frame lag and frame dragging around it, which maintains. Hello? Even 20? Alright. A few minutes. Try to finish this and do one last search around it, which maintains the gravitational pull of the horizon. The effects from the sum of the while mitigating the effects from the of the forces of electron capture interactions to the density from the sum of the frame driving force and the gravitational pull, which maintains the event horizon from so yeah, this is definitely while matter being attracted toward the singularity due to All right, let's try this one. Last one, and then I gotta get ready and go. Oh, interesting stuff. See how wrong I am now. Sure, yes. Interesting. Okay. Your query synthesizes many advanced concepts related to black holes in physics at the most extreme scales, but it is not possible to combine them into a single equation for quantum gravity. The ideas you mentioned highlight the very reasons why physicists still do not have a working theory of quantum gravity. Okay. Yes, it does. This is why I have these questions. So, the complex interplay of classical quantum and thermodynamics affects near black hole singularity represents the ultimate frontier where current physics breaks down. Okay, so we've identified. Yes, it understands us now. I feel like it's not saying that I'm wrong now. It's actually agreeing with literally what I've been saying the entire fucking time. Okay, so here's a breakdown of the concepts in your query and why they cannot be reconciled with a current theoretical frameworks. The unphysical nature of a black hole singularity, infinite density, the singularity where mass is compressed to a point of zero volume. And infinite density is a prediction of classical general relativity, not a physically expected reality. Yes, I know. That's why I'm saying that maybe the Higgs field has something to do with it, or the removal of the Higgs field, or whatever the hell happens to the Higgs field because of the singularity's rotation toward the speed of light, because it's still a mass it's rotating, but it's being distorted because it's rotating at the fucking almost the speed of light, but it's not a photon and therefore cannot actually go toward the speed of light. It cannot do the speed of light. There are particles, I think the only other ones would be like a neutrino or things that are almost at that mass that can travel up to the speed of light, but not obviously a big giant black ball of whatever the hell it might be. So yeah, that makes sense. Yes, but that's also why maybe the Higgs field is what's giving the mass number. Maybe that's what's being affected, and because there's a volume, it exists. It exists in space somehow, even if it's the personification of extinction, as I theorize it to be. So the infinity is simply indicates the general relativity breaks down. Yes, the need for a new theory, a valid theory of quantum gravity, would not result in singularities. One of the primary goals of quantum gravity is to resolve what happens at the center, where quantum effects and gravity are both immense. But black holes result in singularities. Wait, a valid theory of quantum gravity would not result in single, but it isn't it not a singularity? I mean, well, I guess the idea of obviously zero volume, infinite density, yeah, it would be measurable, I suppose. But I think no, I think I mean, maybe the equation at this step where it's considering, maybe it's like it wouldn't result in a singularity, but when you take the integral of it, it does. I think that's where it needs to be rethought of. Is you kind of get the equation, but then you look at using derivatives or integrals to actually describe the a level of comprehension to to understand the singularity, because it's in a different dimension, kind of, because it's affecting the 3D reality that we live in. So, maybe, I mean, the effects obviously are extra dimensional because they affect the 3D space physically, like in such a way that it literally affects space itself. So, vacuum energy and black holes, cosmological coupling, a 2023 study found evidence suggesting that black holes gain mass in a way consistent with absorbing vacuum energy. That oh, I didn't even know that. That's interesting. That's why I like asking these questions, because I'm learning all these other things that have been observed. So this is a recent development and not yet consensus view. Other physicists arguing that black holes do not absorb vacuum energy. That's interesting. That is very interesting. A source of dark energy, the concept of black holes containing vacuum energy is highly speculative, though could be a source of dark energy. I mean, if we're getting particle antiparticle pairs at the event horizon in the form of neutrinos, maybe. I mean, the dark energy is the quantum gravity. That's the gravitational waves, is it not? That's maybe dark energy is the quantum gravity all along. The Higgs field near a black hole, symmetric restoration at the extreme temperatures and densities approaching singularity. The Higgs field is theorized to return to a symmetric state. If this occurred, fundamental particles would become massless, though this would not stop gravitational collapse. This is what I'm saying. Okay, yes. And this is why integrals and derivatives are an important aspect of finding the equation, the correct equation, because it's breaking a dimension of space. It's breaking the freaking Higgs field, basically. So, interesting, yes. But obviously, waves are coming from it, affecting the Higgs field around the singularity. So, black hole vacuum decay. Another theory suggests that primordial black holes could trigger the decay of the Higgs vacuum, leading to catastrophic end of the universe. The fact that this hasn't happened yet places constraints on the early universe. So, yeah, interestingly enough. Frame drag and gravitational forces. Frame drag, as you noted, rotating black hole drags space-time with it. The effect predicted by general relativity is enormous near a black hole. It influences the motion of matter, including its orbital dynamics and formation of jets. Yes, thank you. You finally fucking see it how I saw it. Oh my fucking god. That is what I've been saying. Yes, frame dragging is going to be important in understanding the gravitational pull, because it's the sum of the motion, the force of motion, that's effect of masses, right? That's how Newton's equation works. Rotational masses in space, even if they're not rotating, they still have a gravitational pull, but there's stuff that's happening over time. Oh my god. I mean, there's also electromagnetic forces that exist. There's other forces that can influence that, as well as vacuum pressure and the difference of vacuum energy between one mass and another within space. Yes. So gravitational dominance, while the strong nuclear force is powerful, extremely short distances, gravity accumulates over mass. For a neutron star on the verge of collapsing into a black hole, the cumulative gravitational force from the total mass overwhelms the short-range repulsive force. That's exactly what I was saying. Thank you. Particle interactions inside the black hole, electron capture, beta decay inside a collapsing star, electrons are forced into protons to form neutrons, yada yada yada. Process degeneracy pressure. However, if gravity is strong enough as the formation of a black hole, it overwhelms the degeneracy pressure. Yes, it does. Annihilation of Hawking radiation. Blah, 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 blah. Yes, why a single equation is impossible. Ultimately, the concepts you combine cannot be unified into a single formula of quantum gravity because fundamental theories of physics, general relativity, and quantum mechanics break down in the regimes you described. But we at least acknowledge and figure out where the breaks are happening, and that's at least the first step that I feel like we need to make collectively if no one else has actually made them yet. The concepts you highlight illustrate specific phenomena that a successful theory of quantum gravity must be able to explain, such as how gravity and quantum mechanics interact at the most fundamental level, what replaces a singularity at the center of a black hole, how information is preserved during black hole evaporation, a problem known as the black hole information paradox. Yes, theoretical physicists are actively working on various approaches to quantum gravity, including string theory and yada yada yada. Yada yada yada. So we know now the question that works, right? That makes sense. Where we're at, what we're trying to explain. There we go. That is the end of the video. God damn, that was an exploration, but we got there. We finally got there. So, better question. We're gonna try that question with other thinking robots.